an earlier lesson, we often have to factor out a GCF first. In fact, that's what we should have been doing on all of those. We should be thinking, can I factor out a GCF? Now, the ones I gave you at the beginning, we couldn't. So we're just kind of putting another layer onto these problems. So now, always look for a GCF whenever you see one of these. So do I have a greatest common factor in these three terms? Sure, I can pull out a 4. When I do that, what am I left with? X squared plus 3x minus 10. Now what I do is I factor what's in parentheses if I can. Now you may not be able to. So let's put my negative 10 here in my little factor tree. Factors of 10 that I can get to sum to 3. Now I know since this one's negative, I'm going to have one positive and one negative factor. How about 5 and 2? So how can I combine 5 and 2 so that I get a positive 3? Well, I have a positive 5 and a negative 2. So bring down your 4. If students make a mistake on this one, it's usually they forget to bring down what they factored out. I know it's x and x, and it's going to be plus 5 and a minus 2. Again, we can have these in any order. This is usually what we do. We usually put the monomial term out to the far left, and then it doesn't really matter. I mean, it does when these get more complicated. If I end up having squares and cubes, I usually try to go in some sort of descending order. I am pretty happy no matter what order we get here. Okay, try this one. Again, pause the video here, look for GCF, and see if you can factor what is in parentheses. All right, welcome back. So what can I pull out here? I've got a common factor of 2t. Then what do I have left? Got a t squared plus 4t plus 3. Now, in our first lesson on factoring, that's as far as we got. We were done. I don't think there were any that came out to where we could keep going, but there may have been. But now we have an extra tool in our tool belt. Now we know how to factor trinomials into two binomials. So I'm expecting to be able to factor this. Now, I might not be able to, but I think I can. There's only one way to factor 3. You can't go wrong. Well, I guess you could. 3 times 1 is 3. And 3 plus 1 gives me the 4. So factors of 3 that multiply together to give me 3, but when I add them, I get the middle term, and there we go. And if I were to FOIL that back out, we would typically, you'd go ahead and FOIL it out and then distribute that 2t through, just kind of reverse what we did. We should get this expression here, and I leave that up to you. Okay. Recall in an earlier lesson, I said it's very nice if we can pull out a common factor, or if we have a negative number, it's sometimes easier to pull that out. It's harder mentally for us to use our process when this first term is negative, when the t squared term, the x squared term is negative. So let's go ahead and pull out, what do I have? I can pull out a negative 3. And even if I just had a negative, I'd pull out a negative and work with it. I have a hard time mentally going through when that x squared term is negative. I can pull out a negative 3 from all those. And what do I have left here? X squared plus 2x, and then minus 9. Make sure you can do that. You can mentally distribute that back through. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 2x, negative 6x. And then a negative 3 times a negative 9 is positive 27. Careful with those sign changes. Now, can we factor this any further? You may not be able to. So negative 9. Factors of negative 9, we can go 9 and 1, or 3 and 3. And neither one of these allow me to combine to that middle term. So this is just as far as we can go. If we could, we go ahead and factor it.